continuing our example that uses the airfare data, what we want to do is find this least squares regression line for the data and give the slope, and then interpret the pieces in context, and we'll look at residuals as well. So first, getting our least squares regression line, let's go back to GeoGebra. So in GeoGebra, we have our airfare data in there. We're at the scatter plot. You can actually close down. You don't need to see those statistics right now. But when we're at this screen showing the scatter plot, we can notice is down in the left-hand corner, it says regression model, and then it just says none underneath it. If you click on this drop-down menu, it's going to open up all these different options here. It's kind of like the different ways we can fit different functions to our data. And all we want to focus on is linear. So if we go to regression model and select linear, it's going to draw that line. It's going to perfectly draw the line that best fits our data, and it's down here that we get our equation for the line. And it's this step where we really need those extra decimal places. If this rounds to 2 decimal places, if we use this function, it gets thrown way off. So again, just be sure to go to these 3 bars here, go down to settings, and make sure where this automatically goes to 2 decimal places, make sure you have at least 4 or 5 is even better too. And that'll help immensely with rounding. So this right here is our equation for the line. Something you want to be careful of when doing homework or exams, it only says y here, and it should say y hat. It's a tiny difference, but it's a very important difference because y values are only at the points that are drawn. Y hat values are what are mapped by this line here. So in copying this function down, we want to write down that y, and then we need to throw that little hat there, equals 0.13726x plus 81.76364. Another way you can see the equation of these lines is you can actually use the name of the variables. So where y is represented by airfare and x is the distance, you could write it as predictions for airfare, keep that little hat on there, equals 0.13726, and then where you have x, you can actually write out the word like distance, plus 81.76364. This can be nice just to make sure that when you eventually get numbers, it gets plugged in the right spot. But this is a way to write that least squares regression line. So once we have this, we can interpret the slope and the intercept. So for the slope, so that's our B1, the number that we get out is 0.13726. And as I said, this slope is describing that if we increase x by 1, this is the change in y. And something I like to do is kind of write out a quick interpretation, and then after getting that, it's easier to put the sentence together. So following that, if we increase x by 1, this is the change in y, is that if we increase, and it's going to be distance by 1, then 0.13726 is the change in airfare. So having this written out kind of shortly, and this by no means is a final answer here, it's just a way to kind of put the pieces together, this helps me see, okay, if we increase distance by 1, that's essentially saying if we travel 1 extra mile. So if we travel 1 more mile from Baltimore, so if we increase our distance by 1, or if we travel 1 more mile, And again, that number is always 1. Changing x, we always think about increasing by just 1 unit. So this is the change in our airfare. So what we want to notice is it's positive, so that means the airfare is increasing, and it's increasing by this amount of money. So what we could do is, this is money, so rounding this down so that it makes sense, this would be the idea of 14 cents. So if we travel 1 more mile from Baltimore, the airfare increases by 14 cents. And something we might want to throw in there, if we travel 1 more mile from Baltimore, the airfare maybe tends to increase by that much, just because this is all prediction. And we're working with this moderate strength here, so it's not definite that it will increase by that 14 cents, but there's this trend. It tends to do this. So with these interpretations, it's always good to throw in that kind of loose wording there. Given the y-intercept, so our y-intercept is the value that's not being multiplied by x. So that's our b sub 0, and we get this 81.76364. And similar to what I do up here, I kind of write the same thing here. So it's the idea if x is 0, this is our value of y. So if distance is 0, airfare is 81.76364. So what this is saying is if we travel 0 miles from Baltimore, we'd pay an airfare of $81.76, which that doesn't make too much sense there. Because if you live in Baltimore and don't travel, you're not going to have to pay an airfare to not go places. So you could go with that this doesn't make sense. Something you could think about here is the idea that with your airline ticket, without taking into account distance at all, you have this cost coming through. So this could be the idea of a flat fee on your tickets, that like no matter where you travel, you're going to have to pay this much, and from there it increases. So you could say there is a flat charge of $81.76 on flights from Baltimore. But that's kind of a tricky interpretation, but that's one way to look at it. So sometimes you can think of this as a charge that's already in there. So that would be interpreting our slope and our y-intercept there. Then we have estimate the cost of a ticket if they are traveling 200 miles from Baltimore. So what we're given here is a distance, meaning we're being given a possible x value. And the whole point of having this prediction line is so that we can make these predictions. So what we can do is predict airfare knowing a value for the distance. So what we're going to do is predict airfare, and using our equation, plug in this 200 miles for the distance. And then we can calculate the prediction for airfare. So throwing this into the calculator, we're going to get out 109.2. I'm just going to round to 2 decimal places since this is going to be a cost. So if we travel 200 miles from Baltimore, we predict that the cost of the ticket will be $109.22. So, and we need to make sure we bring through that this is a prediction, or this is what we expect to occur, or it's an estimate, because there's probably a different actual value that they're going to pay for the ticket. So if we travel 200 miles from Baltimore, the expected airfare is $109.22. So, from there, which airfare has the largest residual, and what is the value of that residual? So, going back to our picture that we drew, or even using GeoGebra, what we can see is that there's this point here. This point that's creating this large distance away from the line. And what we want to do is figure out what is that point that's creating this largest residual. So finding this coordinate, I mean, the quickest way would probably be to notice that it has the largest airfare. So we want to find the point that has the highest airfare within our data set. So going back to our data, which is so long ago, here's our data. The value with the highest airfare is occurring here, Miami. So we have this observed value. So it's Miami. And what we observed was that traveling a distance of 946 miles, we had an airfare of $350. And what it looks like is that what we observed is much higher than what we would have predicted. So we can visualize the largest residual, finding the actual value of the residual. We have our observed, again, X is our distance, Y is our airfare, and for residual, we want to take the Y value of our observed minus the Y value of our predicted. So what we need to do is find our predicted value. And again, that predicted value always comes from the line. So what we want to do is see what is our predicted airfare, because we want a comparison of this airfare of $350 minus what we expected to have paid. So what we want to see is what would we have expected to pay if we traveled that same distance. So we want to use our equation of the line, plugging in the same distance as what was traveled to go to Miami. So for our airfare, we're plugging in that distance to see our predicted value, which is 211.61. So, getting this predicted airfare, now we can compare the two airfares by plugging that in right there. And using that subtraction, 350 minus 211.61, we get 138.39. Now, residual tells us two things. It tells us the difference in terms of what was observed and what was predicted. So what they actually paid had a difference of $138.39 than what we would have expected to. Also, what comes through is the fact that this is positive. When we have that positive residual, remember that means that it's an underestimate, as we saw in that graph. So what the residual tells us and how we can interpret it is that for the ticket to Miami, the linear model underestimated the airfare by this $138.39. So we find these residuals, we can create this interpretation of how is the linear model behaving, is it underestimating or overestimating, and by how much. Now it's interesting to look at these large residuals because this is where we might have outliers, and that's something we're going to do later on is see with such a large residual, is this value actually an outlier or not?